Hey guys, so today I'll be going over transition metals, complexes, and magnetism. Magnetism, what is it? It is a property occupied by atoms that can be determined through the number of unpaired and paired electrons in its orbital, and magnetism is separated into two categories, paramagnetic and diamagnetic. To determine the level of magnetism of an element, we look at its electron configuration and specifically only look at the transition metals. So paramagnetic are transition metals with unpaired electrons, which means that it has interactive with the magnetic field. An example here is of cobalt, and as we can see, the electron configuration here has three unpaired electrons, therefore making it paramagnetic. Next, we have ferromagnetic. Ferromagnetic is technically paramagnetic as it is interactive with the magnetic field. However, this contains solely only three elements, basically iron, cobalt, and nickel. Therefore, we can see here that an example being given here is nickel. Therefore, it is ferromagnetic. Diamagnetic are transition metals with paired electrons. This has the least interaction with the magnetic field. An example here is silver. So if we look at the electron configuration of silver given right here, there are no unpaired electrons. Therefore, the given example is diamagnetic. So to make it easier, ferromagnetic has the most interactions with the magnetic field, and then paramagnetic, and lastly we have diamagnetic, which is the least interaction with the magnetic field. So move on, we have ligands. Ligands are ion or molecule that bonds with a transition metal atom to form complexes. Ligands are formed when the electron orbitals are split, causing one or more orbitals to move to a higher energy level. So the splitting of electrons, the degree of the split depends on the transition metal core that the ligands is attracted to it. So when the electrons are splitting too far, the electron will fall down to the sublevel below and fill in the electron orbitals accordingly. So as mentioned before, the electron's orbital can split, and as you go further right on the spectrochemical series, the complex is more likely to have a really far split and causes the electron to fall down to the sublevel below, and it will fill in the electron orbitals below. An example we have right here is iron ion, one bonding with fluoride and the other with CO. Therefore, we can expect that the electron configuration to look something like this. And based on this, we know that this ion right here is paramagnetic. But then this one with unpaired electrons, we also think that it is paramagnetic. However, it is actually diamagnetic. Why is that? So as we mentioned before, the fluorine right here has lower energy due to as given from the spectrochemical series. Therefore, it has a smaller split compared to CO, which is right here. And due to that split, the electron configuration would look like this. And as the electron of this ion moves up, the electron would eventually be moved down to the sublevel, fill in the sublevel right here to look somewhat like this. Therefore, this ion is no longer paramagnetic as it has completely paired electrons, making it diamagnetic. While this has not of a big split, therefore it remains the same, making it paramagnetic. And that's it for today. Thank you.